Alright, in section 3.5 they talk about imaginary numbers, and we'll get into that in just a second. So they talk about a polynomial in question 1, and it has a degree of 6. It has zeros of 0, 4, minus 7, and the 0, 0 has multiplicity 2, and the 0, 4 has multiplicity 3, meaning it's exponent. Number 2, if a is the 0 of the polynomial, then x minus a must be a factor. If a is the 0 of multiplicity m, then x minus a to the m must be a factor. Number 3, a polynomial of degree n greater than or equal to 1 has exactly n zeros if a 0 of multiplicity m is counted m times. If the polynomial function p has real coefficients, and if a plus bi is a 0, then you know a minus bi is also a 0. The reason for that is when you talk about imaginary numbers, like 1 minus 5i, its conjugate, 1 plus 5i, always travels in pairs. If you find 1 0, it's imaginary, it's got its conjugate as well. So if you got minus 7i, you also have positive 7i. If you got 3 plus 8i, you get 3 minus 8i. They travel in pairs. Okay, so number 7 says complete the factorization. Okay, so you pull out an x squared, set that equal to 0, and you get 0, 0, meaning 0 appears twice. X squared plus 4 equals x squared equals negative 4. When you take the square root of a negative number, that negative comes out and the real part stays inside, and then you can always simplify that just to 3i. Okay, so square root of negative 4i is the negative gives you the i, and the square root of 4 gives you the 2, and the fact that you took the square root gives you the plus or minus. So there's your 0, 0, 2i, and minus 2i. Okay, with this one we factor out an x, and then we plug the rest into the quadratic formula, and notice we get a negative under the square root. We know that negative is going to give us an I, and the square root of 4 is going to give us a plus or minus 2. And so you got 2 over 2, which is 1, plus 2i over 2, which is just I. And you got plus or minus, so 1 plus I and 1 minus I. These are imaginary or complex numbers. B, what does the factorization look like? Well, x minus each one. And when you distribute that negative in there, that's what this looks like. Number 12, you factor it into these two, and each one is set to 0. And this one you get plus or minus the square root of 2. Real answer. Here you get the square root of negative 1, which is plus or minus I. Imaginary answers. So you get 1 minus I, 1 minus a negative I, 1 minus root 2, and 1 minus a negative root 2, which simplifies down to this. On this one you factor out an x, so you get x equals 0. This other part, you use a, b, and c here to plug into quadratic formula, and you get imaginary numbers because that's a negative 3. Okay, so the negative comes out and it's an I, and the square root just stays over the 3 because you can't simplify square root of 3. So you get 1/2 plus or minus I root 3 over 2. Okay, and so these are your factors. So 0 is multiplicity 1, this one is multiplicity 1, this one is multiplicity 1. 27, this guy is a difference of squares, and this first one is difference of squares. The second one is sum of squares. There's no formula for that. So each one of these guys we set to 0. The first one we get minus 3/2 and positive 3/2, and the second one we're taking the square root of a negative number, so we're going to get I. The negative gives you the I, and the square root of 9 is 3, square root of 4 is 2, so 3 over 2, plus or minus. So x minus 3/2, x minus and minus 3/2, x minus 3/2 I, x plus 3/2 I. And each one of those has multiplicity 1. Number 29. Okay, you do synthetic division with -1 and it works. And now you've got a quadratic with 1x squared plus 9. And you solve it by taking the square root of -9. That gives you plus or minus 3i. So now you got -1, 3i, and -3i. And that's your factored polynomial. 37, they want you to come up with the polynomial of degree 2. It has zeros of 1 plus I and 1 minus I. So 1 minus I and 1 minus 1 plus I. When you distribute the negatives, right, you have to write that as x minus 1 plus I and x minus 1 minus I. Okay, so you want to write it like that first with each of the zeros. But when you drop the parentheses inside here, you get x minus 1 minus I. There you go. X minus 1 plus I. Okay. 40, you want degree 3 with zeros of 0 and I. Well, if you know I is a 0, then minus I is a 0, the conjugates. So you get all three there, and that's your answer. Degree 4 with zeros of 2i and 3i. Well, conjugate of 2i is minus 2i. Conjugate of 3i is minus 3i. So there's your 4 answers there. 54, you could have tried 1 minus 1, 3 minus 3, 9 minus 9, as well as 1/2, 3 halves, 9 halves. So I tried 3, and it works. Now I've got a quadratic. Okay, and I plug that into the quadratic formula, and I get a negative under the square root. Remember, negative 20 is square root of 4 times square root of negative 5. Well, square root of 4 is just 2. And the negative underneath is going to come outside and become an I. And the square root of 5 just stays where it is. So now you got 2 over 2 plus 2 over 2 I root 5. So that these both cancel and you just get a 1 plus I root 5. So there's your plus and your minus along with 3.